Welcome to an introduction to statistics, brought to you by Parkbench Tutors and narrated by David Hopcroft. For more information about Parkbench Tutors, please visit parkbenchtutors.com. In this podcast, we shall introduce a few simple and useful pieces of math to help in your understanding of regression and correlation. Our previous podcasts have only involved one variable, but we can have two or more variables. Where there are two variables, the data is said to be bivariate. Examples of bivariate data could include height and weight, age and height, length and breadth, and so on. This table shows bivariate data. The two variables are the height and the mass for a group of students. We want to see if there is a relationship between the two variables. We can do this by making a chart of the results as a scatter diagram. The scatter diagram for the previous table is shown here. In theory, there is no limit to the number of variables that can be introduced. For a house, we could have size of rooms, age of house, value of house, council tax paid, and so on. The more variables we have, the harder it would become to show any connection or relationship between them all. So we focus here on looking at bivariate data and trying to see if there is any relationship. Our table is for a group of students and records their height and their mass. When the data are shown in a chart called a scatter diagram, we can draw an ellipse that includes all the data points in the area. The general relationship is that smaller values for height have a smaller mass. We say this ellipse illustrates a positive or direct correlation. Now let us consider another set of data. The height of students and their math score are shown as bivariate data. Let us look at the scatter chart. In this case, the scatter diagram can be included in an ellipse that shows a negative or inverse correlation. You might think this is an unlikely result, and that would be correct, but the sample was only for 10 students. That should remind you of the need to take into account the sample size. Here we have another very small sample showing the data for height and mass of another set of students. The scatter diagram shows no correlation for this small sample. The data set here looks for a relationship between height and a mark for a science test. The data appears to show a positive correlation. The marks increase with height. This would be unexpected, but it might be that this data was obtained from students of different ages. Younger students would tend to be shorter and would have less knowledge compared to the older students. Choosing the scale can be important in trying to perceive a correlation. Here the data are scattered and no clear correlation is obvious. Now suppose that I squash one of the scales. Now it looks as if my data are possibly part of a straight line. You need to be careful with this sort of presentation, since if you squash one scale sufficiently, any data will appear to be a part of a straight line. Just as the previous tables were for bivariate data, we can also have bivariate frequency distributions. This one has some relevance between it, records results from two different tests for the same group of students. Now for a little math revision. The equation for a straight line is given by y equals mx plus c, where m and c are constants. M is the gradient and c is the y-intercept of the straight line. We will start with a very straightforward linear equation. Y equals 2x plus 4, and then complete our table to show values of y for different values of x. Now we have a completed table. All we need to do is make our chart. And we have the straight line graph for the equation y equals 2x plus 4. We can figure out two things from this chart. Any point on a straight line must satisfy the equation for that line, and any 2 points will define the unique straight line. We can show this very simply. Take the equation y equals 6 minus 4x. we calculate the values of y when x equals minus 3 and when x equals plus 3. They are 18 and minus 6. Now we plot these 2 points to get our straight line. We can use the straight line graph to find values. When x equals minus 1, then y has a value of 10. The gradient, or slope, for a line joining 2 given points is the distance travelled in the y direction divided by the distance travelled in the x direction in moving from one point to the other. In this example, the distance travelled in the y direction was 10 units and in the x direction is 2.5 units. The gradient equals 10 divided by 2.5, which is 4. If we have a straight line graph, then we know the equation is of the form y equals mx plus c. From the graph we can then determine the equation. The y-intercept is 2, so c equals 2. To get from A to B, we take 2 steps down the y-axis and 1 step along the x-axis. The gradient will be minus 2 over 1, so m equals minus 2. The equation will be y equals 2 minus 2x. The table here is for varying values of m for the equation of the form y equals mx plus 4. We can see there is a value when x equals 0 in this case, when the y values will be the same. We plot the y values on a chart for each line. We can see that what happens is that the lines will pivot around a central point. Any linear equation can be multiplied or divided through without altering the straight line graph. In this case, the equation x plus y equals 1 is multiplied by 2 to give 2x plus 2y equals 2. We obtain the same straight line for both equations. You will come across simultaneous equations in the study of statistics, so here is a reminder of how these are solved. We start by eliminating one of the variables, either by adding or subtracting, or by multiplying one or both before adding or subtracting. We can then solve the resulting equation for one variable. All we then have to do is substitute that value into one of the equations to determine the value of the other variable. In this example we have 2 equations, 2y equals 6x minus 10 and y plus 2x equals 10. We will rearrange these so that it is easier to follow, so y equals minus 2x plus 10. Now I can multiply the second equation by 3 to give 3y equals minus 6x plus 10. I can now add the equations to eliminate x. I am left with 5y equals 20. So y equals 20 divided by 5, which is 4. Now I can substitute this value into the first equation, so that 8 equals 6x minus 10, or 8 plus 10 equals 6x. X equals 18 over 6, which is 3. This ends our podcast, brought to you by Parkbench Tutors and narrated by David Hopcroft. Thank you for watching and for listening. We wish you success in your studies. For more information about Parkbench Tutors, please visit parkbenchtutors.com.